Good morning. All right, today we're talking about modeling with expressions. So here we go. Interpreting parts of an expression. All right, so an expression is a mathematical phrase that contains operations, numbers, and/or variables. Okay, the terms of an expression are the parts that are being added. Okay, they use the word added. It could really be added or subtracted. We'll get to that in a second. A coefficient is the numerical factor of a variable term. That's a whole bunch of big words to basically mean that a coefficient is the number that's in front of the letter. Okay, so when you see a variable, you see something like 8x. Okay, the coefficient is the 8 and the variable is the x. So this whole thing is one term because it's 8 times x. The 8 is the coefficient, the x is the variable. Alright, there are both numerical expressions and algebraic expressions. So if you have a numerical expression, it means it's just all numbers. If you got an algebraic expression, it's got letters and numbers. So it's got variables and it's got numbers in there. And here we go. Alright, so we got a few examples. Identify the terms and coefficients of the expression. The expression that they give us is 3p plus 5q plus 9r. So 3p plus 5q plus 9r. Alright, so they ask us what are the terms. Well, the terms, this is how I like to do it. I like to just put a box around each thing. So we have 3p, that's one term. We have positive 5q, that's the second term. Then we have positive 9r, that's the third term. Okay, so all the terms that are being, or all the things that are being added, okay, those are your terms. Okay, if it asks you what are the coefficients, okay, so these are the terms. The coefficients are the numbers in front of the variables, or the number in front of the letter. So when they ask you for the coefficient, then you would just put 3, 5, and 9. Alright, 3, 5, and 9. Because the 3 is in front of the P, the 5 is in front of the Q, and the 9 is in front of the R. Alright, another example, we have 15 minus 3x minus 5y. Alright, so once again, if they ask us for the terms, okay, if they ask you for the terms, you're basically just boxing everything up. So the first term is 15, the second term is a negative 3x, because that's minus, and then you have the last term is a negative 5y. Alright, so each little thing there, each little part is a term. If they ask you for the coefficients, this is going to get a little bit different because remember we said the coefficient is the number in front of the variable. So if it's the number in front of the variable, we only have two variables, x and y. Okay, so our number in front of the x is negative 3, so that's the first coefficient. And our number in front of the y is a negative 5. So that is our second coefficient. Alright? We don't need that. Alright, here's a story for us. It says, the price of a case of juice is $17. Fred has a coupon for 15 cents off each bottle in the case. The expression to find the final cost of the case, of juices is 17 minus 0.15 B, where B is the number of bottles. Okay, so the correct terms of the expression. Okay, here's our expression: 17 minus the 0.15 B. 17 is the first term. And then negative 0.15b is the second term. Okay, and then our coefficients, okay, our coefficients down here, it asks us what the coefficients, remember, it's just the number in front of the letter. So the 0.15, the 1500ths, that's what's in front of the b. So negative 0.15, okay, that is your coefficient in front of the b. All right. Alright, this is a good question because this is what's going to happen on your STAR test a lot of times. It says, Sally identified the terms of the expression 9a plus 4b minus 18 as 9, 4, and 18. Explain her error. Okay, so it says Sally identified the terms. Okay, well, if Sally was identifying terms, okay, we have 9a plus 4b minus 18. So the 9a, the plus 4b, and the minus 18, those are your three terms. It looks like Sally was trying to name the coefficients, but she didn't really even do that right because she included the 18, and the 18 can't be a coefficient because it doesn't have a letter. Alright? So, there we go. Now, down here, you're going to see this a lot. What is the coefficient of b in the expression b plus 10? Well, if you just have b plus 10, the coefficient in front of the b, if there's nothing written there, that is a 1. Okay, so that means our coefficient is a 1. Alright? Because there's just one b. Mathematically, 1 times b is just b. So there's no reason to write the 1. Alright? Here we go. Now, this is going to be important. Everybody always wants to know, when am I going to use this? Well, here you go. Alright? In this section, you're going to learn how algebraic expressions in real-world situations can be related. So, Jill is buying inkjet paper and laserjet paper for her business. She buys 8 more packages of inkjet paper than P packages of laserjet paper. Inkjet paper costs $4.95 per package, and laserjet paper costs $8 per package. What does the expression 8P plus 4.95 times P plus 8 represent? Okay, so we have this expression 4.95. Okay, now, in the problem, it tells us that P is packages of laserjet paper. Okay, so this is 8. 8 is the cost per package. Okay, 8 is the cost per package of the laserjet. And then P is the number of laserjet packages. Okay, so now we're adding. Okay, the $4.95 is the cost per package of the inkjet. And you have to multiply that by the P plus 8. Remember, it says she got 8 more inkjets than of the laser jets. So this is the number of inkjet packages. So if this is the cost per package and this is the number of package, okay, this is the total cost for the laserjet paper. And that means this over here has to be the total cost of the inkjet paper. So that means this whole phrase up here, the 8P plus the $4.95 times P plus 8, that is the total cost of P packages of laserjet paper and P plus 8 packages of inkjet paper That's the total cost of all the paper that was bought. Okay, that's the total cost of all the paper that was bought. All right? All right, now we're going to do some comparisons. Okay, we're going to compare using less than or greater than. We may even throw in an equal sign. Okay, so less than or greater than. Hopefully you remember that this symbol means less than. I know we all learned the big alligator mouth side faces the bigger number, so that means the number over here is less than the number over here. Okay, so when we see this one, okay, that means greater than. Okay, once again, the big open alligator mouth side, that's the bigger number. So this number over here is greater than whatever's over here on the smaller side. Alright, so here's what we're going to think about. Okay, we have X and Y give the populations of two different cities. They tell us that X is greater than Y. Okay, they also tell us that Y is greater than 0. Okay, they tell us Y is greater than 0 to make sure that we understand that everything that we're dealing with is a positive number. Okay, we're not dealing with any negative numbers here. Everything is positive. Alright, so X is bigger than Y, and Y is bigger than 0, so all positive numbers. So they want us to compare the expressions and tell which one is greater. So they ask us about X over Y, and then Y over X. Okay, so remember, X is greater than Y. Well, if X is greater than Y and X is on top, that means this is an improper fraction, because the bigger number is on top. Which means if we have an improper fraction, this has to be greater than 1. Alright? Over here we have Y over X. Well, if the Y is smaller, okay, then this is just a proper, just a regular old everyday fraction, which means this number is between 0 and 1. So if this fraction is bigger than 1, and this fraction is between 0 and 1, what does that mean? Okay, it means that this X over Y is going to be greater than Y over X. Okay, so hopefully that makes sense to you. Hopefully you can see all that, and we'll be good to go. Alright. Now, we said up here that X over Y was greater than Y over X. So now they ask you about this. Alright? So it says choose the correct statement to compare the two expressions. Well, the first thing you've got to do is you got to figure out how does this compare to this. So hit pause for a second, make sure you look at it, make sure you think for just a second, okay? And you're really looking at this to try and figure out what is different, okay? Alright, now that you're back, okay, hopefully you hit pause, hopefully you actually thought about it, hopefully you figured out that the only thing that's different about these and this one is they added a 2 in front of both fractions. Okay, so they did 2 times the X over Y and 2 times the Y over X. Well, if we multiply by 2 on both sides, and this one was already bigger than this one, and you multiply on both by 2, okay, that means this one is still going to be bigger, because we did the same thing on both sides. Okay, so this top answer here, I hope you can see it, is 2X over Y is greater than 2Y over X. Alright? Alright, now, this is one of the other things you're going to have to do today. You're going to have to be able to write an expression, okay, write an expression given a word problem or like a verbal phrase, some sort of real world scenario. Alright, so it says consider the price of a car plus 8.5% sales tax. Okay, so the price of the car plus 8.5% sales tax. So we want to start off by thinking about, we've got to find the base price of the car. Okay, we don't know what that is, so we're going to use a variable. Okay, then we've got plus, the operation, they told us plus. Okay, so we're adding. Okay, now we have 8.5% sales tax. Well, how do I find 8.5% sales tax? To find 8.5% sales tax, I have to multiply the 8.5% times the original cost of the car. Okay, well, you can't just multiply by 8.5%. You've got to change that percent to a decimal. So when we change that percent to a decimal, if it is 8.5%, we're going to move this 2 times. Okay, so this becomes 0.085. Alright, so we have the price of the car, and then we're going to add it to 0.085 times the price of the car. Now, when we add these two things together, these are like terms. Okay, this is 1p, and this is 0.085p. So here the coefficient is 1, here the coefficient is 0.085. Alright, so when we add those together, we're going to get 1.085 times p. Okay, and that would be our final answer. Okay, that's how we would write that expression. Alright, well, I hope you took some good notes. I hope you're ready to get started on your hope you have a great day. So we'll talk to you later. Bye.